To better understand the benefits of adding all-natural Amaferm to your nutrition program, we've animated its effect on fiber digestion. Here's the life cycle of an ordinary rumen fungi. The mature sporangia release motile zoospores into the ruminal fluid upon feeding. The zoospores attach to the fiber and produce a germ tube which penetrates the outer layers of the fiber. Then, rhizoid development begins as the hypha branch out in all directions, physically breaking open the fiber and secreting enzymes that create otherwise inaccessible attachment sites for the bacteria. This process breaks down feeds into various metabolites, including volatile fatty acids, peptides, ammonia, methane, and carbon dioxide. Now, we'll add Amaferm to the ration. Watch what happens. Amaferm dramatically shortens the lag or dormant stage of the sporangia, greatly increasing the production of viable zoospores. The increased number of motile zoospores results in more zoospores attaching and encysting into the outer layer of the fiber. At this point, Amaferm's effect on rhizoid development is quite impressive. Amaferm stimulates an increase in branching and enzyme secretion. All of a sudden, many additional surfaces for the bacteria to attach are created. Not only are more able to attach, their growth rate is also directly stimulated by Amaferm. The increased morphology and physiology of the fungi and increased bacterial numbers results in increased feedstuff degradation and utilization.
Our laboratory at Washington State University has carried out basic fundamental research since 1993, has attempted to elucidate the mode of action of direct-fed microbials. As molecular biologists, we have studied the mode of action of a variety of aspergillus and yeast-based direct-fed microbials that are fed to animals to accelerate fermentation. We have discovered that Amaferm uniquely stimulates the physiology of rumen fungi and bacteria. We feel this stimulation is of critical importance with respect to fermentation in the animal. The role of rumen fungi in the natural events occurring in an animal relates to its ability to invade plant fiber and mediate the first steps of breakdown. Within the ruminant animal, there are a variety of species that mediate this breakdown. Those include bacteria, protozoa, and fungi. Our laboratory has concentrated our efforts looking at fungi and bacteria and the effects of aspergillus on the growth and physiology of those organisms.
Side by side, you're able to see the significant role that research has shown Amaferm to play in digestion. First, 3 times the number of motile zoospores are releasing, and 2 times as many are attaching to the fiber and germinating. Secondly, the morphology of the fungi is increased. Actual cell mass has been measured to be 27% more with Amaferm in the diet versus the control. You can see a great deal more branching on the Amaferm-stimulated rhizoid, which is responsible for physically breaking open more of the fiber, creating more attachment sites for the bacteria. Thirdly, fungal physiology is increased. As branching is increased, you can see that there's simply more enzyme secretion, over 87% more. This is also responsible for degrading the fiber and creating more attachment sites for the bacteria. Finally, bacterial growth and multiplication are directly stimulated by Amaferm, with research showing up to a 3-fold increase in fiber-digesting bacteria. The increased morphology and physiology of the fungi and bacterial numbers result in more complete fiber degradation and increased microbial yield of volatile fatty acids and microbial protein. So, what does this Amaferm-enhanced rumen ecosystem mean to the performance and health of your animals?
Okay, my name is T.G. Nagaraja. I'm a professor of microbiology in the Department of Pathobiology at Kansas State University, Manhattan. I have worked in the area of rumen microbiology and rumen fermentation for the past 25 years. And my research has focused on how particularly the feed additives that we feed to ruminants how those feed additives affect the microbial population and those fermentation products produced in the rumen, and how those changes reflect in terms of animal performance. Amaferm, by stimulating rumen microbial population, rumen microbial growth and activity, would result in increased fiber degradation, which would increase the digestion in the rumen, resulting in higher production of short-chain fatty acids like acetate, propionate, and butyrate. And these fatty acids are the major source of energy to the ruminant animal, because these fatty acids get absorbed from the rumen, and the ruminant animal will use them as and metabolize them for energy. In addition to increased fermentation in the rumen, we also have increased microbial cell production. And these microbial cells, particularly bacteria, when they leave the rumen and go to the lower GI tract, they get digested by the ruminant animal, and they provide the protein necessary for the animal. In fact, microbial protein is a major source of protein to the ruminant animal. So by stimulating microbial population, we are increasing digestion at the same, which will provide more energy to the animal. At the same time, we are providing more protein to the ruminant animal.